Now we discuss some problems in complex analytic functions. That is, we verify whether a complex function is analytic or not. So we define a complex function as f of z. W is equal to f of z, and that f of z is u of xy plus I into v of xy. Say complex function f of z is equal to u of xy plus I into v of xy, where u of xy is the real part and v of xy is the imaginary part. The necessary condition for a complex function f of z is analytic. That is, the necessary condition for an analytic function is the real part and imaginary part, that is u and v, satisfies the CR equations, that is Cauchy-Riemann equations. Dou u by dou x is equal to dou v by dou y. Dou u by dou x is equal to dou v by dou y, and dou u by dou y equal to minus dou v by dou x, and dou u by dou y is equal to minus dou v by dou x. And we write in the other form as ux, dou u by dou x is ux is equal to dou v by dou y is vy, and dou u by dou y is uy, and dou v by dou x is minus vx. So the necessary condition for a complex function is analytic if it satisfies the CR equations ux is equal to vy and uy is equal to minus vx. Any one of these CR equations is not satisfied, then the complex function is not analytic. That is, if ux is not equal to vy, then this complex function is not analytic. Or if ui is not equal to minus vx, then also the complex function is not analytic. And the sufficient condition for a complex function to be analytic is if the real and imaginary part satisfies the Cauchy-Riemann equations ux is equal to vy and uy equal to minus vx. That is, the real part and imaginary part satisfies the two equations ux equal to vy and uy equal to minus vx, and also these partial derivatives dou u by dou x, dou v by dou y, dou u by dou y and minus dou v by dou x both are continuous, then that complex function is an analytic function. Okay, so to verify whether a complex function is analytic, we verify whether that function satisfies the Cauchy-Riemann equations or not. Okay, for example, I take one polynomial function f of z is equal to z. We know that z is x plus iy. We have f of z is w, and that w is u plus iv. So u plus iv is x plus iy. That is, u is equal to x and v equal to y. The real part is x and the imaginary part is y. U equal to x and v equal to y. So u equal to x, then ux is dou u by dou x. So dou u by dou x is differentiating u with respect to x, dou u by dou x is 1. Uy, that is differentiating u with respect to y. Uy is, if there is no y term, so differentiating u with respect to y, the value is 0. Similarly, vx, that is, we are differentiating v with respect to x. There is no x term in v, so the derivative of v with respect to x is 0. Now vy, that is, we are differentiating v with respect to y. So derivative of v with respect to y, we have v is y, so derivative v with respect to y is 1. We take cross multiply, that is the condition, that is ux is equal to vy. This is our condition, ux is equal to vy. So ux is 1 and vy is also 1. So ux is equal to vy. The first condition, first CR equation. ux is equal to vy, and second CR equation is uy is equal to minus vx, but here both uy and vx both are 0, so uy is equal to minus vx. So this function f of z equal to z satisfies the two Cauchy-Riemann equations. Ux is equal to vy and uy is equal to minus vx. And also the partial derivatives are ux is equal to 1, uy equal to 0, vx equal to 0 and vy equal to 1. All are constant functions. And constant functions are continuous. So the partial derivatives are also continuous. So therefore this function f of z equal to z is an analytic function. So f of z equal to z is an analytic function. Okay. So this function z satisfies the Cauchy-Riemann equations and all the partial derivatives are continuous. Therefore f of z equal to z is an analytic function. Now we take on another example. That is, I take f of z equal to z bar. Then u plus iv is, we have z bar is conjugate of z. Z conjugate. Z conjugate is x minus I. So u is, we have the real part is x and v, the imaginary part is minus 1. So ux is, we differentiating u with respect to x, it is 1. Uy is 0. Vx is 0. Vy is minus 1. Our CR equation is ux is equal to vy. But here ux is 1 and vy is minus 1. So 1 is not equal to minus 1. So ux is not equal to vy, but uy is equal to minus vx. Both are 0. So ux is not equal to vy. So the first CR equation, one CR equation is not satisfied. Therefore this function z bar is nowhere analytic. Okay. So f of z equal to z is analytic, but f of z equal to z bar is not analytic. Okay. Now we choose another example. F of z equal to z square. So u plus iv is x plus iy the whole square. Z is equal to x plus iy. So u plus iv is x plus iy the whole square. So we have x plus iy the whole square is a plus b the whole square. A plus b the whole square is x square plus 2ab. 2ab is 2x into iy, that is I 2xy plus b square. That is iy square is, we have I square is minus 1. Okay, I square is minus 1. So iy square is minus y square. So x square plus 2yxy minus y square. So then the real part is u is equal to the real part. Real part here is x square minus y square. And the imaginary part is v equal to 2xy. Imaginary part is v equal to 2xy. So then the partial derivatives, ux is equal to differentiating u with respect to x. Derivative of u with respect to x is, derivative of x square is 2x. Y term 0. Then u differentiating u with respect to y, x square 0 minus derivative y square is 2. Vx. Derivative of v with respect to x. With respect to x is 2y. Vy. Differentiating v with respect to y. With respect to y it is 2x into derivative of y is 1. So 2x. So we have ux is equal to vy. Ux is equal to vy. And uy is minus 2y. Vx is 2y. So that means uy is equal to minus of minus 2y. It is 2y. So uy is minus vx. So ux is equal to vy and uy equal to minus vx. So the Cauchy-Riemann equations are satisfied. And also the partial derivatives are 2x and 2y. Both are polynomials and they are continuous. So Cauchy-Riemann equations are satisfied and partial derivatives are continuous. So this function f of z equal to z square is an analytic function. Now we discuss on another example. So we take the polynomials z bar and z square. Both z and z square are analytic. Both are polynomials and they are analytic. Now we take on another function, that is exponential function. Exponential function e raised to z. Exponential function e raised to z. We have e raised to z is e raised to x plus I. Z is x plus I. And we have e raised to a plus b is e raised to a into e raised to b. E raised to a plus b is e raised to a into e raised to. That is e raised to x into e raised to iy is, we have e raised to I theta. E raised to I theta is cos theta plus I sin theta. So e raised to iy is cos y plus I sin. Cos y plus I sin. That is e raised to x into cos y plus I into e raised to x into sin. E raised to x into cos y plus I into e raised to x into sin y. So the left side is we have, it is u plus iv. That is u is, the real part is e raised to x into cos y. The imaginary part b is equal to e raised to x into sin. U is e raised to x into cos y and v equal to e raised to x into sin. Then ux, differentiating u with respect to x. So u is e raised to x into cos y. Differentiating u with respect to x, y is constant. So cos y is a constant. Derivative of e raised to x is, it is e raised to x. So e raised to x into cos y. Uy, differentiating u with respect to y, x, e raised to x is constant, then derivative of cos y is minus sin y. Vx, differentiating v with respect to x, e raised to x into, derivative of e raised to x is e raised to x into sin y, and y is e raised to x into derivative of sin y is cos y. Okay, so ux is e raised to x into cos y, vy is e raised to x into cos y. So both are same. Ux is equal to vy. So ux is equal to vy. And also uy is minus e raised to x into sin y and vx is e raised to x into sin y. So uy is equal to minus vx. So ux is equal to vy and uy equal to minus vx. So CR equations, Cauchy-Riemann equations are satisfied, and also the partial derivatives are exponential function, trigonometry function, sine and cos. Both exponential function and trigonometry functions are continuous functions, and also the product of two continuous function is continuous. So we have e raised to x into cos y is continuous, e raised to x into sin y is also continuous, and here also e raised to x into sin y and e raised to x into cos y, both are continuous. Therefore Cauchy-Riemann equations are satisfied and partial derivatives are continuous. This function e raised to z is an analytic function. And also, the derivative of e raised to z is derivative of e raised to z is, we have a derivative is f dash of z. F dash of z is ux plus I vx. The formula for a derivative f dash of z is ux plus I vx. Ux is e raised to x into cos y plus I into vx is e raised to x into sin y. That is e raised to x, we are taking e raised to x outside, then balance is cos y plus I sin y. That is e raised to x into cos y plus I sin y is e raised to I. That is e raised to a plus a into b is e raised to a plus b. E raised to x plus I y is e raised to z. So derivative of e raised to z is e raised to z. Okay. Now we have another example. F of z equal to, we take one trigonometric function sin z. Take one trigonometric function sin z. We have sin z is sin x plus I. Sin x plus iy. Sin x plus iy is sin a plus b. Sin a plus b is sin a cos b plus cos a sin. So sin x into cos iy plus cos x into sin iy. And we have sin cos iy is hyperbolic function cos hy plus cos x into sin iy is hyperbolic function sin hy. And we have sin iy is I sin hy. We put I here. So this I cos x into sin hy. So u plus ib is sin x into cos hy plus I into cos x into sin hy. So u is sin x into cos hy and v is cos x into sin hy. So ux is equal to, differentiating with respect to x, derivative of sin x is cos x into cos hy, and uy is derivative of sin x is sin x, then derivative of cos hy is sin hy. Derivative of cos hy is sin hy and derivative of sin hy is also cos hy. Then vx, derivative of cos x is, we have derivative of cos x is minus sin x. Minus sin x into sin hy, and vy is cos x into derivative of sin hy is cos hy. That is ux is same as vy, cos x into cos hy, and uy is minus vx. So the Cauchy-Riemann equations are satisfied. Ux is equal to vy and uy is equal to minus vx. Cauchy-Riemann equations are satisfied. And also sin x, cos x, sin hy, cos hy are the functions in the derivatives. These functions are continuous. Sin x, cos x, sin hy, cos hy all are continuous functions, and the product of two continuous functions is continuous. Therefore, these partial derivatives are all continuous. Ux, uy, vx, vy are all continuous. Therefore, this function sin z is analytic. Also, derivative of sin z is, we have f dash of z. F dash of z is, we have the formula is ux plus I dx. Ux is cos x into cos hy plus I into vx. Vx is minus sin x into sin hy. We write it as plus I into minus sin x into sin hy. So we have cos x into cos hy is, actually it is cos hy is cos I y minus sin x into I sin hy is, actually it is sin iy. Sin iy is I sin hy. So cos x into cos iy minus sin x into sin iy. Cos a cos b minus sin a sin b. Cos a cos b minus sin a sin b is cos a plus b. Cos x plus i. Cos x plus iy is cos z. So derivative of sin z is cos z. So we discussed the analyticity of some complex function. First we take polynomial functions, then exponential functions, then trigonometric function sin z. Similarly, we have to verify the other complex, other trigonometric function cos z, etc. Okay, thank you.